So I'm hoping to dig into it, and help provide some more clarity there. So, but to understand it, it really helps to understand, first of all, the mission. And the mission of the ONF has really expanded in this last year. And I think this is quite important to understand. So, our operators have tasked our community really with a massive undertaking. I mean, it's a humongous undertaking. It's almost unbelievable that such a small organization in the ONF is going after something so large, but it all started with technology transformation. I mean, it really started with SDN and the whole notion of disaggregation and starting to break the network into pieces. And that's led now into virtualization and then more recently even into cloudification. And that's still a core and critical component of the ONF's mission and our vision. The next big piece is taking this and starting to create platforms. And this is in a way to start putting the pieces together, but also to build these platforms on white box and open source to make them be consumable in a new way in this new economy. And then the third big piece, I don't know if you all think of the ONF in this context, but our operators are really asking us to help try to play a role here, and that's in the area of ecosystem transformation. And that is also the title of this track this afternoon. And really what we need and what the operators are asking for is a new supply chain that's ready to deliver on this mission. And that is a big undertaking, a massive, massive undertaking. It's a many billions of dollars kind of market, some big, large, established incumbents that we all know. There's been a huge amount of consolidation over the last years, and that has led to a need to really try to form a new ecosystem that can deliver in this space. So, I think a big question here is that maybe you could turn on my lav mic if it's. Is this on? Can you hear me? Maybe you can, so I can see the slides a little more easily. Actually, although I might get some feedback. Maybe that's not going to work. So, but can open source pursue such a disruptive agenda? I think is a big question. It's really, in many ways, the underlying question that is being asked by the industry. And we've been at it now 7 years, and over that period of time, we've learned a number of things. Number one, the incumbents have trouble pursuing such a disruptive agenda. I think we probably all recognize any surprises in the room in that topic. I think that they have established businesses, and this is not an easy thing to undertake. That this whole spectrum of open source pieces is too hard for operators to assemble. Are you guys hearing feedback, or is it just me? Yeah, so something's off. I think we maybe have both mics live. Okay, let me go back to the podium mic. That's better. Sorry. So, these open source pieces are too hard for operators to consume, and they, to assemble them and consume them on their own, they don't have the core expertise today. They'd love to have it. Getting to that point is not an easy undertaking. There's a journey to get there, and they need to find a way to get there. And that the incumbents, to date, only package these open source pieces into proprietary solutions. They're happy to consume pieces, but really what they expose to the end user is still a proprietary solution that comes as a monolithic thing, in essence. And so the open sourceness that's underneath doesn't really benefit the operator. Because remember, the operator is not just after being able to call it open source, nor is the operator really after just cost reductions. What the operators are asking for is to have a level of openness so that they can innovate on their own over time as well, not to be beholden to a single incumbent. So to have open source pieces buried underneath is really of no value to the operator, per se. And a disruptive agenda requires a committed focus that, when you're trying to do something big and disruptive, it's not something you do as a pastime, and you really have to roll up your sleeves and dive in. And so because of all these reasons, we've come to understand that we need a special model for the agenda of the ONF. The ONF is doing something really unique, really disruptive, really audacious, and what do we need to do to go after this? So, as we've come to this, we've realized that what's out there in many cases is maybe what I'd call a consensus model for open source, where you sort of start by building a broad community. You start by finding consensus, something that many can align behind, and then you build common pieces that all the different participants can use. And when you're building these pieces, the incumbents have expertise, And so, because they really have the engineering capabilities today, and so what you find then is that the incumbents play a majority role in these projects often, you know. And as a result, number 4, what you wind up to is this type of approach, this consensus-based approach, really lends itself to infrastructure plays. And that's why you see from some of these types of projects more NFVI types of project outcomes. That, you know, if you're focused on infrastructure or open stack related kinds of things, multiple incumbents can consume that, operators too, and so everybody can align behind that. Oh, we all love OpenStack, let's work on OpenStack together. And so that's a model that works. But out of that you get infrastructure, and so you can only go so far up the stack in a way with this type of approach. And the ONF submission is really pushing the envelope here, a couple of steps ahead of this, and beyond what might be considered as pure infrastructure, and so it makes it difficult. So to that end, we've really come up with a different model, which is really an operator-led, curated open source model, if you will. And so, you know, again, 4 steps I've broken it into, but they're sort of flipped on their head. You identify a disruptive end goal that you're trying to achieve that's very importantly backed by operators, backed by whoever's going to be consuming this, not by who's going to be trying to sell something, you know, to the operators. And then you have a small group of committed partners fund the seed creation of the technology. And this really does require dedicated engineering talent with the right skills to go after whatever problem you're going after. With this, and you start to develop this seed, then attract a small handful of suppliers that are related to that. You know, you start to build out, rather than trying to start big right from day one. Start with a small committed team around the table that can work intimately together, and then build out. And then ultimately you achieve critical mass and attracting a broad community. And so, I mean, if you really read through the numbers, it's almost like, you know, the reverse. They're kind of like one's clockwise and one's a counterclockwise way of going after the problem. And the ONF is really pursuing what I'm describing here on the right. And in this presentation today, I just want to walk through these 4 steps on where we are here. So, you know, the ONF is executing on this 4-step plan. I think we're having, really pretty incredible success. Definitely challenges ahead, and definitely some issues we need to address, but I think we're often headed in the right direction. So let's walk through then these 4 steps. So step 1 is that the operators come together with a common end goal. So back in March, how many of you are familiar with this announcement and the reference design concept within ONF? How many of you knew about it maybe before today's keynotes? So maybe about half. Maybe, yeah, about half. So you know, it's relatively new. What it really is that our 8 Tier 1 operators who lead the ONF, the logo is on the left here, have created this curated open source model where the operators build consensus around exemplar platforms using selected components. And then the operators jointly create common reference designs for the access and edge. These are to be gold standards for what's to be deployed in production networks. The operators are committing resources from beyond their CTO teams, but into their architecture, design, into their operations teams to be able to take this really to production in a serious way. And then the operators are to craft RFPs or refer to these reference designs in RFPs, and that this work is supposed to be used in the procurement process. So on the back end, when it's really going to deployment and when money's really going to be spent, there's a relationship back to the reference design process. And then lastly, the intent to form a Keiretsu teams of ecosystem operators and aligned supply chain partners. These are these small teams that can work together and pursue these disruptive agendas. The operators are committed to reconstituting the supply chain, and they're looking for a supply chain that is aligned with a belief that it's good to leverage open source and white box in production networks, not that it's a sin to leverage such technologies. So this was all announced in March. Pretty audacious plan, a pretty big step up. This was additive to the ONF's work, to what we had been doing to date. And visually, the process looks something like this. And Guru used a slide like this. I won't belabor the slide, but really, this bottom track is maybe think of it as a more open source approach, where you build components and from there platform solutions and head towards the market. And we've added on this reference design component. And the reference design component is, the operator partners of the ONF working together to decide what reference designs to invest in, and then building teams to focus on and build these reference designs, and then ultimately use them in the procurement process on the tail end of this flow. The reference design process, as I mentioned, it's a curated partner-only process at the front end. So the operator partners lead it, but the supply chain partners are intimately involved. If the ones that are aligned and have, can contribute to this. And so this is overall with the ONF, that's roughly, to start, about 15 companies. So it's not closed, others can come into this process, but again, it's starting small, starting with critical mass, with people that are aligned, and then being able to sort of drive towards an end goal. Process-wise, how many of you are ONF members, out of curiosity? Again, about half, maybe a little more. So just to understand the process, and I'm not going to belabor this, but it influences, like on the last day of this conference, there's a member-only day that gets into the reference designs. So, the reference design creation is a partner activity, operators and aligned supply chain partners. Once the reference designs...
If people don't know that they are members, just look at your badge. Because if your badge says you're a member, then you're allowed to come in.
It seems right. There may be, there's a small handful of people that have registered that didn't even realize, I think, that they were, their companies were already members of the ONF. Big organizations have lots of moving parts. So for members then, the draft reference designs get released to membership for review, and it goes into a review period. And so all 4 of the reference designs we're talking about are now entering this review period. So very exciting. That happened this week. It was announced today. A press release went out. Furthermore, it's important to understand, this is more of a business track, that there's a RANZ licensing attached with this. And so this is a zero-fee bilateral licensing for any intellectual property that appears in these reference designs. So all of our membership shares this intellectual property pool, if you will. If you participate as an ONF member and you participate here, you're not going to get sued for implementing a reference design. But furthermore, if you have an issue with a reference design, you need to raise that issue now during this review period. So there is a legal aspect to it, but that's important to make this whole machinery work. And that leads then to public release of the reference designs. And at this point then, the operators refer to and procure based on these reference designs. And we have our operator partners who are all committed to using this process in the procurement process. But then it gets opened more broadly as well. And so the intent and hope over time is that more operators participate, consume, use the reference designs in their processes as well. So that was really step number 1, bringing a small, mighty community together to drive things forward with a clear operator direction. Step 2 is around now creating the common components and platforms to build that seed to get the ball rolling. And to that end, you've heard some today about the different projects and platforms we have. Essentially we have tracks that align with all of these here during this week. And virtualized broadband, SEBA, Trellis is around a white box fabric, SDN controlled, UPAN for next generation SDN, ODTN for virtualizing the optical transport network, disaggregating it and SDNizing it. And then things that are a little further out, but in the mobile space and then in the whole edge cloud space, work that the ONF is undertaking. So all of these exemplar platforms, which have all been underway to some degree, even as we kicked off this reference design process, are attached. The ones that are closer to market, the top 4 are attached to reference designs now. The operators picked those reference designs that could be pursued more immediately, and they had more immediate plans to take to deployment. And so, there's a one-to-one correlation here with an open source exemplar platform that's completely open source from the ONF, and then hand in hand with a reference design that's going through the processes that I described just in the last slide or 2. And so that's sort of what the big picture looks like in terms of the different components and platforms that the ONF is assembling. Again, Guru used a version of this slide, so I won't belabor things that he covered, but I'm going to go a little deeper so you understand the pieces. So what you see in the middle here can be thought of as a core data center or an edge cloud data center. It connects to the WAN off on the right and to the subscribers often to the left, but then is essentially building what's in the middle in a cloud-native, cloud-like way with a spine leaf fabric, a white box wherever possible in the middle there, and then specialized components that are sort of bookended for specialized optical on the right, specialized access on the left, which could be in the form of access optics like PON or RF for radio. And the way our projects stack up here is that really maybe think of these almost as the infrastructure or the physical layer component projects that virtualize the physical layer in the RAN, in the PON space, next generation SDN really in the Ethernet space, and then in the optical space. A layer on top of that, a number of infrastructure components for SDN control and tying it together. XOS and then service elements for the different spaces and marketplaces. And the best way to understand all these different projects we have is that, if you look at it this way, think of like all of this together is like the chord universe of pieces that we have. But each of the exemplar platforms and reference designs tends to pick a specific subset that can be assembled into a platform that the operators are ready to consume. So, yes, there's a big picture. All the pieces fit together. Think of it as a lot of different Lego blocks, but that's a lot of different pieces and a lot to chew on all at once. But if you can pick out certain pieces of it and assemble them into something that's tighter and can be hardened and taken to production now, there's an appetite for that. And that's the vehicle we're using to try to help drive the market forward, provide clarity for how the operators are assembling pieces, and to get critical mass behind common assemblies of pieces. Because that's the feedback we were hearing at the beginning of the year that, every operator's doing it in a different way, and we don't know how to participate because there's just too much variability in there. So, specific assemblies of pieces look like, SEBA for virtualized broadband. It looks like the NFV fabric for the white box spine leaf SDN fabric. It's UPAN for the next generation of fabric and the P4 enabled infrastructure. And ODTN for the disaggregated optical components. Guru went through these. Just the way to think of the two, we call trailblazing projects are that, MCORD has a slice of this, a profile of this. It's virtually a Helm chart that just pulls from all the different projects a particular assembly of the components to go after the mobile space. And then the cord itself, the grand picture that we have is that going after the edge cloud, all of the pieces that we're working on are infrastructure components that help build to this unified whole, and that this can actually deliver multi-access to the different access types, and at the same time add cloud platform services to be able to deliver next generation applications or multi-tenant applications on top of this infrastructure living at the edge of the network. So I'm going to touch down one layer deeper, and then if any of these then strike a nerve for you, I encourage you to find the tracks where they go deeper still, of course, right? That's kind of how this goes. But so SEBA, and just trying to understand it and its relation to RCord, it's really it's a derivative of RCord. It's built on all the RCord work, all the RCord experience. RCord was really the first successful chord work. It's where chord started, but we learned a lot. And so we took all those learnings and back in and made some adjustments to SEBA specific to what the operators were asking for. So, the first adjustment is that it's not just for residential, but it addresses both residential and backhaul, mobile backhaul use cases, which is a big increase in the market size for it. Pretty natural extension, but still a pretty important extension. The next one is that it's designed to be lightweight, much lighter weight than RCord was designed to be. To get the footprint down, people are recognizing that the edge is moving closer and closer to the user, maybe even out to the radio tower or beyond, and what does that look like? And so it's really optimized for this minimized footprint. It's now Kubernetes-based, where Arccord is really VM-based and VNF-based, and it was based on that level of NFV thinking. So we've really moved to a cloud-native kind of way of approaching this. And OpenStack is now just an option. It's optional, and it's only needed if you wanted to introduce VMs for a certain additional functionality. But base SEBA doesn't require OpenStack or VMs at all. It's designed to be high speed. And what this means is that the default data path for data coming from a user to the internet doesn't touch an x86. And in a virtualized world, every packet would go through an x86. And instead, those packets can fast path right through the fabric and can really run at 100 times faster through the infrastructure. And what that means is a direct relation to the footprint. And instead of having to build big racks and have lots of servers to handle lots of subscribers, you can crunch it all way, way down into a quarter-size rack. I encourage you to go see the demos at the end of the hall, and there are, I think there's more than one demo of SEBA and different configurations of SEBA, but in all cases, you're starting to look at things that are pretty interesting and incredibly powerful in something that you could, if you're really strong, you probably could lift it, And then lastly, but very importantly, operationalized. You've got to plug this into real networks with real existing OSS systems, and so FCAPS and OSS integration is a very important part of this work in this project. And visually, I'll just walk through the pieces quickly, right? So that you understand that it starts by virtualizing the PON layer, the OLT. It wraps it in something called Volta, which is a project you may have heard of. And so it actually makes the whole OLT look like an open flow switch and exposes northbound the interfaces as if it were just an open flow switch, so that the rest of the network can treat it just like a simple Ethernet network. And then you can run ONOS on top of it, and then you can run a set of ONOS apps on top of it. And the operators want this because historically these OLTs were big chassis that had baked into them all the little features like DHCP and multicast and all these different, the commodity pieces, but every vendor had their own version of it. So it means every time an operator would take on a new OLT, things would change. It would take a whole pile of time to prove out and be able to consume the new OLT. If you can virtualize those components, extract them from the hardware, run them in a common open source platform, you can swap out the hardware components much, much more rapidly with less variability. And that's really one of the beauties and visions of going down this route, and it's why the operators care about it so much. You add some aggregation switches to build the network. In the core diagram I showed you before, I had a huge fabric with lots of racks. Here, two switches can often do the job if you're going to get the thing down into a really small footprint. But it can scale up if there were a need to scale up. You can attach compute, and you attach it to the backbone of the network. And then, importantly, at this point in time, subscriber traffic can run straight through from the user all the way through to the internet without touching the compute. And that's what I meant about fast path, and that really has huge implications. The NEM layer runs on top of this and provides the FCAPS and OSS interfaces northbound, both to legacy or to ONAP, open source-based solutions that might be in common. And this in whole then is the SEBA pod that really takes what used to be, vendor proprietary chassis and is now providing a virtualized, disaggregated, open solution for next generation PON and broadband access. Lastly, everything you see in the colors above is all software, right? So it's actually running on the compute, of course, as containers, and but it's basically blowing that up so you can understand what's in there. And then lastly, and I had some questions about this at lunch, that BNG was designed to be a workload option, so it can run in multiple places, and that's because different operators have different goals, and so that was already discussed. But I just want to make it clear that some of the options actually take BNG and start to run it in the OLTs or in the AG switches in very interesting, new, novel ways, using next generation SDN work that we're doing. So it's not that we've punted on the BNG work and pushed it out, but that this is a way to be able to adopt SEBA rapidly and at the same time pursue quite a disruptive agenda for subscriber management. So that's a big picture for SEBA and for broadband access. And in itself, a huge market, a lot of interest with operators. So next up and quickly is the NFV fabric. This is the open, leaf spine fabric based on OpenFlow. And it's, as described here, ONOS with a number of ONOS apps running on top of an open white box switches. This OFDPA is a software package from Broadcom that turns a Broadcom switch and exposes an OpenFlow northbound interface. It runs on a different spectrum of Broadcom silicon. This is a solution that's up and running in early production. It's used inside Cord, it's used inside SEBA. And so this is an infrastructure piece that's consumed throughout the ONF portfolio of pieces. And you can see a pretty impressive demo of it down at the end of the hall if you haven't seen it before, where everything is controlled in a common way northbound. So how does this connect to the next-gen SDN? This is a common question, and what's that relationship? And so there's a natural synergy and lineage and flow from one to the other. That with the next-gen SDN, you can still keep some of your existing infrastructure if you so choose. With OpenFlow and the ONOS controller can still talk OpenFlow down. But we introduced Stratum, which is this new white box thin switch that's an ONF project that Google was talking about, and Google is on a path to consume rapidly. And this exposes, instead of OpenFlow northbound, it exposes P4 runtime and a whole set of next generation SDN interfaces that provide for full lifecycle management of the switch, not just for control of the data flows, but everything you need to do to bring up, upgrade, manage the LEDs, the power, the fans, the full life cycle for the switch, as well as very sophisticated management of the flow and behavior of the switch. And then thirdly, and importantly, support for full P4. When P4 is a capability, show of hands, how many people know P4? So lesser known, but important for you to start to understand. And that's, it's another consortium that's actually merging with the ONF. It's around making the switches themselves truly programmable. So you can actually push down the precise forwarding behavior in a programming language into the switch. And it makes it possible to do very interesting next generation things. So Stratum then, there's, ONOS is getting extended to be able to talk to Stratum with the fabric.p4 driver to be able to make all this work together in a seamless way. ONOS is able to consume these P4 programs that describe the forwarding behavior of the switch. And in its ultimate incarnation, with the most advanced silicon, you can actually write specialized apps up top that actually get pushed down into the silicon in the switch and start to run very advanced functionality. And this is something we've already demonstrated and done a proof of concept of, where the SP gateway, that's for the mobile world, that's GTP tunnel termination. That's like for all the data for any user. Today, that all goes through x86s and VNFs. That pushes that functionality down into Stratum switches so that all that termination and the counting and management of those tunnels is done in silicon at 6 terabits per box versus about 40 gigabits per box for a server. So, I mean, the economics there and the shift is tremendous. And so, fantastic potential for this, and there's a lot of interest in this. And our path and view on this is this ultimately becomes the infrastructure and underlayer for all of the ONF's work, because SEBA can use this, and other projects can make great use of this. And so, again, all of our work kind of fits together, and this is the way this fits. And then lastly, for the Exemplar platforms and reference designs is ODTN, which is the disaggregated optical. And just in a snapshot slide, what we're trying to do here is, optics is in some ways is one of the last domains that hasn't been disaggregated. You still buy vendor proprietary solutions, and so all the pieces come together. What we are doing and what our operators are after is breaking it apart so you can have one vendor for the open line system. Those are the amps and the filters. And then different vendors for pairs of transponders. And so the secret here, the way we've simplified and made this approachable, is that we pair and bookend the transponders. So the 2 yellow transponders can get deployed from one vendor, and 2 purple ones from another vendor. And they just can talk to each other. So you can use advanced coherent optics and other things that the vendors want to drive forward and do interesting things with, but run it still all on a common system. And the huge win here is to be able to consume the latest optics rapidly. somebody comes out with a 1 terabit transponder, an operator can consume it without having to rebuild their whole network or wait for their incumbent vendor to be able to support that optic, which is a problem, a big problem today. In its first phase, it's being done in a point-to-point, and that's for often called data center interconnect, and it's a huge market in and of itself, especially with cloud markets and the like. A lot of optics is getting consumed that way. But in subsequent phases, phase 2, it's moving towards multi-point ROADM support, so you can actually build meshes, rings, and do add drop and all those kinds of things, all controlled by ONOS in a common way, all open source. I'd point out OpenConfig and TAPI, those are interfaces. TAPI is an ONF project. OpenConfig is a community project, largely started by Google. But those are open interfaces that are being used to help pull all this together. So that is the ODTN. Again, a track on it here. If this is your space and you're interested in it, opportunities to roll up your sleeves and learn more here. So, we talked about these reference designs. Another way of visually thinking of it is the 2 trailblazing projects we have are kind of follow-ons to that, building on the reference design work we're doing, and we've talked about all this. But what I just want to say is that, today we're announcing that all 4 of these reference designs have been released now to the ONF membership. And so we think this is a big moment. We think we've been, the operators, really, they deserve all the credit because they've been doing the vast, vast majority of the work here. But a lot of work has gone into this over the last few months. The operators are very ambitious about driving this to production, and it's really very, very rewarding now for us to see these now being made public, or at least public to the membership, ultimately fully public. And so a very exciting moment, and we think, we expect that, if we look back a few years from today at this moment and this year, that this will be a really transformative year in how operators have started to behave and for the adoption of open source. So, the next 2 steps, I have fewer slides and we'll wrap pretty quickly here, but so we've gone through step 1 and step 2, which was building a community and then building the seed codes and seed project. But now, to build an ecosystem, it really starts with a small supply chain of ecosystem partners. And we're very pleased that we have started to see this Keiretsu team of supply chain partners come together. And I want to point your attention to this left-hand column. This is really these different categories of how we've started to think about positions that one can play in this new marketplace, in this new ecosystem. And some of the more obvious roles that make a lot of sense, kind of working from the bottom up, are silicon players that provide chips of some functionality. Access equipment players. So this is still a specialized place. If you're doing RF, you're doing specialized optics, there's really a lot of room for innovation and intellectual property and probably higher margins, and that makes sense. But then there's the white box space, the infrastructure as a service space. Those are more servers and storage, white box switches. The expectation is the margins are lower on those. Those are closer to commodity, if not already at commodity. Then a whole, software layer that's both the form of services and platform and sort of how to pull the pieces together, harden the pieces. And then system integrators that help pull all the pieces together, help you build it, deploy it, operate it, perhaps, what that market looks like. So, the operators stated the intention back in March to really rebuild the supply chain, and there are actually a number of new players that appear in here that are new since March. So, I thought I had a slide in there, I don't. But, in essence, we feel like we're doing quite a good job of starting to fill out the positions, but we're not done. That's really the summary takeaway. It's easier at the bottom layers. It gets harder at the top layers. And maybe that's obvious, but it's something that we're grappling with and still working our way through. And I think that what we've heard is that we really need stronger system integration capabilities too. We need horsepower, manpower to bring to bear on this problem. That these operator networks are massive, that the incumbents typically had massive teams they could put on these projects, and to be able to scale up, we need a new level of horsepower to be able to apply to the problem space. And hence you see some of the gaps closer to the top. And so then step 4 is attracting this critical mass and the broader community. And so, Build it and they will come. You might think of it that way. That's from a movie some of you might know. But so this year, as a direct result of this plan, the ONF has added 4 new partners. Those are top-tier supply chain partners, as well as 23 new innovator members. And I could bump that to 24. A new operator joined yesterday at the innovator level. And we're seeing quite substantial momentum and strength and interest in what we're doing. That this new plan, the operators doubling down and really investing in the space, is helping the industry understand where things are going and how to participate and invest. And then lastly, today we're also announcing our newest partner. Infosys has joined just today as a partner with ONF. Infosys, some of you might know, is a top-tier system integrator. Have tens of thousands of skilled software engineers with a worldwide footprint. They're already heavily engaged with operators in a number of engagements in different geographies. And we're very pleased because we think this starts to really fill out the portfolio of that supply chain. Like I mentioned, we need more horsepower in the system integration space, and here we go. So, Infosys started to see some early indications of the operator consumption here. They started to get some early engagements. They suddenly recognized that, wow, there's something really important going on here. And as a direct result, they've decided that they really need to themselves double down here, invest time, money, resources in coming up to speeds and capabilities. And they see this as the next great frontier. They built a whole business around Hadoop and open databases and the like, and analysts are saying that this market is bigger than the public cloud market. Massive, massive opportunity. And so I think they're forward-leaning, they're recognizing the opportunity, and they're, to their credit, rolling up their sleeves and diving in. So with that, thank you.